Good morning, ladies. Welcome to your walkthrough. And the first thing, obviously, that you start with, the most important thing, well, possibly not the most important thing, but it is fairly important, is to write your name. All right, so let's have a look at the instructions that a lot of you often glance over. So always an idea just to check that you've got all the correct pages. The pages are numbered and you've got your information sheet. And the things that are the most important, this instruction tells you that you need to show working out. You cannot just show an answer. Ensure that your calculator is in degree mode. This is particularly for the AP girls because your calculator might have been in radians since your last test or whatever that you did. And also look for information about rounding. All right, so there's no information about rounding here, which means that it will be given in the actual question. Question 1. Solve for x, giving answers to 2 decimal digits where necessary. So firstly, look at the equation, and you got to decide what type of equation. Is it quadratic? Is it linear? Is it exponential? Will you have to use the formula, etc.? So this one is quadratic because the degree of the equation is 2, and that always tells us we're going to equate to 0. So bring the 7x over and equate to 0. Now this quadratic equation doesn't have a constant, which means you're not going to factorize into 2 brackets. You're simply going to factorize the common factor out, which is x, and you'll be left with 5x minus 7 in your brackets, and then your solutions are x equals 0 or x equals 7 over 5. Okay, remember that 7 over 5, we got that by saying 5x minus 7 equals 0, and then effectively solving for x. Okay, question B. All right, now this one is already factorized on the left-hand side, but because there's no 0 on the right-hand side, we need to multiply out. So FOIL the brackets, so we'll get x squared, and then plus 2x minus 5x, and then bring the 6 over, well, first minus 5 times 2, which is minus 10, bring the 6 over. All right, now simplify and get that into standard form. So we'll have x squared minus 3x minus 16 equals 0. Now, ideally, we would like to factorize this into 2 brackets, but you'll see that there aren't any factors of 16 that will add and subtract to give us 3. Our factors of 16 are 16 and 1, 8 and 2, and 4 and 4. So that means we'll be using the quadratic formula here. It's not necessary to write out the formula because it is given to you, so you don't get a mark for that. But for the walkthrough, I'm going to add that in just so that you are sure where it comes from. Right. This next step is important. Your substitution step often gets you at least 1 mark for the method, but sometimes a mark for an accuracy and a method for your correct values that you substituted in, and you've done it correctly into the correct formula. So our B value is minus 3, and inside the surd, that means minus 3 squared minus 4 times our A value, which is 1, and our C value, which is negative 16. Okay, and that's all over 2a, which is 2 times 1. All right, multiply that out. You can use your calculator to help you. Oops. So x equals positive 3 plus or minus the square root of 73 all over 2. Right, if the question had asked you to leave your answer in simplest surd form, then you would stop here. But they have asked you to round off to 2 decimal digits when necessary. So you now need to put these on the calculator and get your 2 different solutions. Remember, one for the plus and one for the minus. So we get x equals 5,77 or x equals minus 2,77. Question C is a surd equation. Now, in a surd equation, you must remember that you always need to check your answers. And the reason we do that is because remember that surd 2x minus 5, on the outside here, there's no sign, which implies it's positive only. When we square both sides, we are we're almost saying that actually if it was negative into root 2x minus 5, we would still get the same answer. But clearly here, negative is not a valid solution on the outside of that surd. So that's why we need to check. All right, but firstly, the method that you use here is you isolate your surd. So our first step, we're going to leave the 2x minus 5 on the left-hand side and take the 4 over to the right-hand side. Second step here is to square both sides. Now, this is a part where often a mistake is made. Okay, when you are squaring, you're not just squaring each individual term. Okay, so what I mean by that is, let's square the left. The square of the square root of 2x minus 5 is 2x minus 5. But the square on the right-hand side, we cannot just simply square x and square 4, because what we're actually doing is squaring the entire left-hand side and the entire right-hand side. Right, so we FOIL effectively. So we're going to get x squared minus 4x, which is minus 8x, plus 16. All right, so now we've eliminated the surd by squaring through, and we now need to get everything onto one side of the equal sign so that we are equating to 0. So 0 equals, we've only got x squared, minus 8x minus 2x is minus 10x, and positive 16 plus 5 is positive 21. Okay, so now we can factorize, and we'll have x minus 7 and x minus 3. Okay, quick check that you factorized it correctly. Multiply the last two terms. Negative 7 times negative 3 does give us positive 21. And then your outers, minus 3x times your inners plus your inners minus 7x does give you negative 10x. So we potentially have two solutions, x equals 7 or x equals 3. Okay, so let's do the check. So the check means we actually have to check the solutions in the original question. Okay, not in any of your steps where you've worked it out, just in case you've made an error. So we're going to substitute 7 into the left-hand side of the equation. So it'll be 2 times 7 minus 5 plus 4. Okay, 2 times 7 is 14, minus 5 is 9, so we have the square root of 9 plus 4, which gives us a total of 7. On the right-hand side, we just have x, which is 7. Right, so x equals 7 is a valid solution because it checks out for the left and for the right. All right, let's check solution x equals 3. So on the left-hand side, we have the square root of 2 times 3 minus 5 plus 4, and that gives us the square root of 6 minus 5, which is 1, plus 4, which is equal to 5. All right, the right-hand side, we just have x, so we substitute 3 in and we get 3. Okay, these two are not equal. The left and the right do not equal each other. Therefore, that is not a valid solution, and so x equals 7 is the only solution. Question 2. Please, it's always important to read the instructions. Too often you go straight to the question and miss out important information. So what's important here is that without using a calculator and showing all working. All right, and this is because often these questions can be done on a calculator, and we need to see that you know how to do it. Secondly, leave answers with positive exponents, meaning that if your final answer has a negative exponent, you could be penalized. Right, so whenever you have negative exponents, your aim is to first convert those negative exponents into positive exponents. All right, now you've got negative exponents inside the bracket and negative exponents outside the bracket. But because we work with BODMAS, we'll focus on the inside of the bracket first. Simplify the inside of the bracket as far as you can go, and then only worry about the outside exponent. Right, so the 2 to the negative 1, we can bring that to the bottom. So it'll be x over 2 to the positive 1. Minus, we'll leave the x at the top. It has a positive exponent, and we bring the 5 to the bottom so that it's a negative exponent. A positive exponent at the bottom. Right, now inside the brackets we get an LCD, leave the negative 1 on the outside, so the LCD is 10, which means that inside on your numerator we're going to have 5x minus 2x. Good, so that gives us 3x over 10 to the negative 1. And now to make that outside negative exponent positive, we can invert the inside fraction. So we'll now have 10 at the top over 3x at the bottom. Okay, question B. You see that we have bases here that are big. Now that almost always means that you're going to reduce those to their prime bases. And depending on this type of question, you're either going to be factorizing or simply simplifying. In this case, we're simplifying because the fraction that you have is all one term. There's no pluses and minuses separating the term. All right, so we're going to start by reducing each value in our fraction. All right, so let's start with the 12. The 12 reduces, remember, to prime numbers. And the reason to prime numbers is because then we can make sure that we've put all the like values together. All right, so it'll become 2 squared times 3. That's 4 times 3, which is 12 to the x plus 1, times 27, which is 3 cubed, to the power of x minus 2. And then 18 reduces to 3 squared times 2 to the 2x minus 1. Okay, now let's distribute those exponents into the exponents on the inside of the bracket. Right, so at the top, we have 2 to the power of 2. That 2 gets multiplied to the outside x plus 1. Right, so 2x plus 2. Then the 3, remember, has an exponent of 1, so that gets multiplied to x plus 1. Then lastly at the top, we have 3 cubed, so 3 to the 3x minus 6. In the denominator, we start with the 3. So 3 to the 2 becomes 3 to the 2 times 2x, which is 4x. And 2 times minus 1 is minus 2. Times 2 to the 2x minus 1. All right, now you're going to collect all your bases that are equal. All right, and remember, when you move exponents either to the top or to the bottom, they change their signs. All right, so let's start with base 2. So we've got base 2, and its exponent is 2x plus 2. There are no more 2's at the top. There's a 3 there and a 3 there, but there's a 2 here at the bottom. So we're going to take those exponents up. So the positive 2x becomes minus 2x, and the minus 1 becomes positive 1. Right, then let's move to the 3. So we move to this first 3 here. That's 3 to the x plus 1 plus 3x minus 6 for this exponent. And then we've got a 3 at the bottom. That's raised to 4x minus 2, so that becomes minus 4x plus 2. All right, now we simplify. So for the 2, the 2x minus 2x cancels out, and 2 plus 1 is 3. Then for the 3, we have x plus 3x is 4x minus 4x, so the x's cancel. Then we have 1 minus 6, which is negative 5, plus 2 is negative 3. All right, so now we have one more step to do. The 2 to the 3 becomes 8. 3 to the negative 3, we bring it to the bottom because we have to leave our answers with positive exponents. So 3 to the negative 3 becomes 3 to the 3 at the bottom, which is 27. Now they've said don't use your calculators. So those are small bases and exponents. They're easy to do mentally. All right, but the moment it's 2 to the 10 or 2 to the 11, then you can leave it in exponential form. Okay, question C looks like it is massive, but the trick with these is always factorization. Okay, we know factorization because there's a plus in the middle, and our aim here needs to be that we can cancel big numbers. All right, these are not possible to do on your calculator. If you try it, it's just too big for the calculator to cope with, and it'll tell you math error. All right, so our common factor at the top, and I know some of you battle with questions like this, so I want to show you something quickly just to help you with it. So if I had 2 to the 4 plus 2 to the 3, over 2 to the 3. Then I can easily see that 2 to the 3 can be factorized, so that we're left with 2 plus 1. And then at the bottom, we've got 2 to the 3. So those 2 to the 3's will cancel, and 2 plus 1 is 3. Okay, check when you multiply. 2 to the 3 times 2 to the 1, we would add the exponents to get 2 to the 4 again. And then 2 to the 3 times 1 is just 2 to the 3. All right, so let's apply it to this question. We're going to factorize the smallest exponent out. So we're going to say 2 to the 2019 is equal to 2 to the 1. Remember, because if we multiplied those back, we would add 2019 to 1. All right, and then plus 1, because 2 to the 2019 times 1 is 2 to the 2019. Then at the bottom, we have 2 to the 2019. Those 2 to the 2019s now cancel, so we're left with 2 plus 1, which is 3. Question 3a, determine the values. Remember, when the S is in a bracket like that, they're implying that there could just be one value, or there could be more than one value, of x for which x squared minus 4x minus 12 is greater than 0. Right, so firstly, we factorize x minus 6 into x plus 2 is greater than 0. All right, now you need some kind of a method to work this out. You've got critical values. Remember, critical values are the values that would make this expression equal to 0. All right, so minus 2 is the smallest critical value that comes from the solution of that bracket, and the other is 6, which comes from the solution of that bracket. Right, now this is a parabola. So effectively, that negative 2 and 6 are the x-intercepts of your parabola. So if you draw a rough parabola going through those two values, we can see that the parabola is positive to the right of 6. It's negative between negative 2 and 6, and it's positive when it's less than negative 2. Okay, but the question is asking for when is the parabola greater than 0? In other words, when is it positive? Right, and we can see that it's positive there to infinity, and it's positive there to negative infinity. And also remember that the critical values themselves are open, because the original tells us it's greater than 0, not greater than or equal to. Right, so our solutions are, the first positive solutions are when x is less than negative 2, or when x is greater than 6. Okay, question 2. What is the value of x, or values of x, when 1 over x squared minus 4x minus 12 is undefined? For that expression to be undefined, the denominator would need to be equal to 0. So x squared minus 4x minus 12 equals 0. That would make it undefined. So factorize to see what are our critical values here, and we would get x minus 6 into x plus 2. Therefore, x equals 6, or x equals minus 2. Now remember, we're not solving for x here. It's not an equation, it's an expression, the original question. But we're seeing which x values would make that denominator equal to 0. Question B, determine the value or values of t given that 2x squared plus tx plus 2 has non-real roots. So they're talking about nature of roots here. So the first thing is to first check it's in standard form, which it is, and now secondly, determine your delta, all right, because it's our delta that we can see what the nature of roots are. We can't just factorize this because we don't know what t is. All right, so delta is our b squared minus 4ac, the discriminant. Remember, that's the value underneath the surd sign in your quadratic formula. And now substitute. So the b value is t, so that's t squared, minus 4 times a, which is 2, times c, which is also 2. And that simplifies to t squared minus 16. All right, for non-real roots, we have delta less than 0. So therefore, t squared minus 16 must be less than 0. All right, and so now factorize. So we get t minus 4. We get t plus 4, which is less than 0. And therefore, our critical values, let's do it on the right here, go from -4 to +4. It's a positive parabola. So we are looking for the negative values because those are what would make it undefined, okay? Because we've got t squared minus 16 is less than 0. All right, so that's between and not including -4 and +4. Okay, question C. Given 2x plus 3y equals 5 and x squared plus y squared equals 13, solve simultaneously for x and y. So the clue that you're going to be solving simultaneously is in the word simultaneous. So before I do this, I want to explain what this means, what you're actually doing. You're given two functions, all right? This is a linear function, a straight line function, and this is actually the equation of a circle. Now, you haven't done that yet, but it's not necessary to answer this question to know that that is a circle equation, but I'm using this to illustrate to you what you're actually doing. So if I had to sketch these two functions, the linear function would look something like that, and the circle function would look something like that. Okay, so as you move up and down the straight line, the x and y values will change, all right, infinitely. And as you move around the circle, the x and y values also change in their own proportion. Okay, obviously to a maximum x value here, a minimum x value there, and so on. When you're solving simultaneously, what you're actually doing is you're solving for the coordinates of the points where the graph meet each other, okay, where they are simultaneous. So in other words, if you look at this first point, the x and y value there are the same for the straight line and the circle, and the x and y value there are the same for the straight line and the circle. All right, now it's possible when you solve simultaneously to get one solution for x and one solution for y. That would be when the straight line touches the circle only at one point. It would also be possible to get no solution. For example, if the straight line was out here outside the circle and doesn't touch the circle. So just from my rough diagram, we're assuming that we can possibly get two solutions. Okay, so let's do it. All right, always start with the easier equation, okay, the linear equation. So what you need to do is put that equation in terms of one of the variables and make the other variable the subject of the equation. Okay, it doesn't matter which one you choose in this case because they're both going to end up in fractions. So if I choose x, then I will take the 3y over 5 minus 3y, and then divide by 2 to get x on its own. All right, so here's our first equation. All right, and now x is the subject of the equation, and this equation is in terms of y. I'm going to label the second equation 2. We now substitute equation 1 into equation 2. So wherever we see an x in this equation, we're going to replace it with that fraction. All right, so x squared means that 5 minus 3y over 2 squared. That replaces the x. Then we've got our y squared, and we've got our 13 on the right-hand side of the equation. Okay, now our aim is to solve for y. We only have y in the equation. So first, let's deal with that fraction in the bracket. There's nothing we can simplify in the bracket according to BODMAS, so we're going to have to FOIL the top. So 5 times 5 is 25. Minus 3 times 5y is minus 15y. Minus another 15y plus 9y squared. And that'll all be over 4 because we have to square the bottom as well. All right, plus y squared equals 13. Now we're going to multiply every term by 4 to get rid of the denominator. So we'll have in the numerator 25 minus 30y plus 9y squared plus 4y squared equals, and then 4 times 13 is 52. Right, so we can see now you have a quadratic. So let's get everything equal to 0. So 9y squared plus 14y squared is 13y squared. Then minus 30y is the only term with the y, so we leave that as it is. And 25 minus 52 is minus 27. Okay, you can factorize. So now we have 13y plus 9. You can use the quadratic formula here as well. And we have y minus 3. Okay, so there are our two solutions for y. Y is equal to negative 9 over 13, or y is equal to 3. Now, to get your corresponding x values, you're going to substitute that negative 9 over 13 back into this equation, because that is the equation where x is the subject. And we can say 5 minus 3 times negative 9 over 13 divided by 2 gives us 46 over 13. And then for when y is equal to 3, we do the same thing. This time you substitute the 3 back into your equation 1, and we get a corresponding x value of negative 2. So on my diagram, my very rough diagram that I did, this coordinate there must have a negative x value and a positive y value. So that will be these two solutions here. X is 46 over 13 and y is this coordinate here matches these coordinates where y is positive and x is negative. Then the other coordinate over there is where our x value is positive and our y value is negative. Okay, now they didn't ask for it in coordinate form, so you don't need to worry about the diagram. You just have to solve for the x and the y. Question 4, given f of x is equal to 6 over x minus 3 minus 1, and g of x equals x minus 3 over 6. Okay, so let's just have a look at some of the information first. Your f of x is a hyperbola, all right? It's in standard form, and your g of x is a straight line function. If you want to rewrite that just so that you can see that it's a straight line, it's effectively 1 over 6x minus 3 over 6, which is minus a half. Okay, so that's the same equation. All right, so let's do some working out. We already know straight from the equation that we have a vertical asymptote at x equals positive 3, because that would make this the denominator 0. We have a horizontal asymptote at y equals negative 1. All right, we're not really interested in your working out when we ask you to sketch a function. We're only interested in seeing the graph, and everything that should be labeled on the graph is labeled on the graph. All right, so let's firstly work out our intercepts. That's the most important thing for these two functions. All right, so let's work with f first. All right, so f of x, for the y-intercept, we're going to let x equal 0. So it'll be 6 over minus 3 minus 1, which is negative 3. For the x-intercept, we're going to let y equal 0. So 0 is equal to 6 over x minus 3 minus 1. All right, multiply everything by negative x minus 3 to get rid of the fraction. So 0 times x minus 3 is 0. Then we have 6. Then we have minus 1 times x minus 3. So it becomes minus x plus 3. Okay, and then solve for x. So x is 9. So our y-intercept of f is negative 3. Our x-intercept of f is positive 9. Right, then for g, let's do the same thing. For the y-intercept, we're going to let x equal 0. So y is equal to negative 3 over 6, which is equal to negative a half. Okay, but we can already see that from our c value in the equation in standard form. Then for the x-intercept, we're now going to let y equal 0. So we're going to have 0 is equal to x minus 3 over 6. Multiply both sides by 6 to get 0 equals x minus 3. So the x-intercept is x equals positive 3. All right, I'm going to erase this information so that we have space for the graph. Right, so I'm going to start with my straight line graph. So my straight line graph has an intercept at positive 3 on the x-axis and at minus a half on the y-axis. Right, and then all we need to do is link those. Okay, that's G. Don't forget to label it. And just check that you've labeled all important points. The straight line only has the intercepts that need to be labeled, so that's good enough. Now we can move on to the hyperbola. So firstly, always start with your asymptote. So we've worked out that there's a vertical asymptote on our hyperbola at positive x equals 3. Label that asymptote that asked you to. And then we had a horizontal asymptote at y equals minus 1. Remember, it's a sketch. It doesn't need to be fully accurate as long as you're going through the correct values. Okay, so this value here is minus 1, and then your horizontal asymptote we label as well as y equals minus 1. Okay, so that's step 1 for the hyperbola. Step 2 are to label your two intercepts. So our first intercept was at y equals minus 3. So here's minus 3. And our second intercept was at positive 9 on the x-axis. Okay, so I'm going to extend this a little bit just to make it look a little bit more accurate. All right, so our x-axis is here, and let's say positive 9 is about there. Okay, so we know it's a positive hyperbola. So it's going to start close to the asymptote over here and go through our x-intercept and then approach the asymptote going down over the x-axis. Then on the other side of the graph, we're going to start close to the asymptotes here, go through our negative 3 and down. All right, and then that is function f. Okay, do a final check. You've labeled all asymptotes, you've labeled all intercepts, and that is your answer. Please use a ruler. I tried to use a ruler on my iPad, but it doesn't really work that effectively. Question 5. A box of 40 calculators is sent to a store. The owner of the store is not aware that 5 of the calculators are defective, meaning that they don't work. 2 calculators are selected at random from the box. The first one is not replaced. They've put that in bold, which means it's important, before the second one is selected. Use a tree diagram to determine the probability that one calculator selected is defective and the other is not. Give your answer as a fraction in simplest form. In other words, not a decimal, not a percentage, but as a fraction in its simplest form. Okay, they've given you a big space there, and the hint there is that that's where your tree diagram goes. So even if they didn't tell you to use a tree diagram, the fact that there's a space there means that there's some kind of a diagram that you need to use to support your answer. Right. So let's start. We've got 2 different possibilities. Okay, we've got defective calculators and we've got calculators that are okay. Now, of the 40 calculators, 5 of them are defective, which means that the remaining 35 are okay. All right, now they said the first one is not replaced, and they're asking you to determine the probability that one calculator is defective and the other is not. All right. So, if we now say that one is defective, the first one, okay, and now the second one, to be defective, means that there are only 4 defective calculators left and 39 in total. That's why they told you it's not replaced. Okay, and that means that if we've taken a defective calculator out, there are still 35 that are left that are fine out of the remaining 39. Okay, however, on your second part of your tree diagram, so here, if we've chosen a calculator that's okay, and we now want to see what's the probability of choosing a defective one, there will still be 5 defective ones in the box of 39 calculators because the first one was okay. All right, and if we choose now one that's okay, then that means there are only 34 left out of the 39 calculators. All right, so the probability that the first one is defective and then the second one is okay, plus the probability that the first one is okay and the second one is defective. Okay, so because they've asked that there must be one of each in your 2 calculators that you've selected. Right, so the probability that they're defective gives us 5 over 40 Okay, so I'm looking here now that the first one is defective and that the second one is okay, is 35 over 39. Okay, then we add. Now we're looking at the second part. What is the probability that the first one's okay? It's 35 over 40. All right, so 35 over 40. And then if we've gone down this line, because the first calculator selected was okay, the probability that the next one's defective is 5 over 39. So we're going to multiply that, 5 over the 39 remaining. Right, use your calculator here. So we have 35 over 156 in its simplest form. Right, question B. A survey was conducted on a group of 100 students to see who would watch the following World Cups: football F, rugby R, and cricket C. The results are summarized as follows. So on the top line, they tell you the total amount that would watch each World Cup. So in the survey, 70 in total would watch football, 60 in total would watch rugby, and 46 in total would watch cricket. Okay. Then the second line tells you who would only watch football, only rugby, and who would watch all three, and who would watch football and rugby, 42. Right. It's easiest to start in the middle. All right. So the people who would watch all three World Cups is 20, and that would go in the middle. Right. The next thing, they tell us that football and rugby is 42. So that means in this intersection here of football and rugby must be 42. Now we've already got 20 in the middle, which means that the remainder then that would watch football and rugby is 22. Okay, now we can move to the next part. They told us that there are 15 that would only watch football, so that would go in that part of the football set. There are 10 that would only watch rugby, so that would go in the rugby set, not intersecting any of the others. And then now we can fill in the remainder. They told us that in total 60 watch rugby, so if we subtract that 22, that 20, which is 42, and that 10, which is 52 from 60, we are left with 8 in this intersection. So those 8 people would watch only rugby and cricket. Now we do the same for the football. We add that 15 to the 22, which gives us 37, and then we add that 20, which gives us 57, and they told us that in total 70 people watch the football, so that means there's a remainder of 13 that watch football and cricket. And then lastly, there are 46 that watch cricket. So 46, we would say 20 plus 13 gives us 33, plus 8 gives us 41, but there are a total of 46 that watch cricket, which means the remainder here is 5. Now it's important to see they don't tell us how many have said that they will not watch any of the 3 sports, so we need to add up all of these values. So the 15 plus the 22 plus the 20 plus the 13 plus the 8 plus the 10 plus the 5 gives us 93. They initially asked 100 students, so that means there are 7 in total that will not watch any of the 3 World Cups. All right, let's look at the question. What is the probability that a randomly selected student will not watch any of the World Cups? All right, so the probability of not any will be 7 over 100. And they didn't ask you how to give the answer. So in this case, I would say write your answer as 0.07 as a decimal probability. And that's the end of section A. Now remember, this is a normal section A paper, a 2-hour paper, where it's all paper 1 work, and section A are the easier paper 1 questions, section B are the more challenging paper 1 questions. The paper that you're going to write is 1 paper, and in section A, roughly half the paper will be some easy paper 1 work and some easy paper 2 work, and then your section B will be some more difficult paper 1 work and some more difficult paper 2 work. Right, section B, question 6a. Given f of x is equal to 2x, so that's a function. Find a simplified expression for f of x plus f of 1 over x plus 1 over f of x plus f of negative x. Okay, so this basically relies on you knowing how to substitute. So for the first one, f of x, nothing's changed. So the first part is going to be 2x. For the second part, they are saying f of 1 over x. That means wherever you see x, substitute 1 over x. So it's going to be plus 2 into 1 over x. The third fraction, 1 over f of x, means we're going to say 1 over our original f of x, which is 2x. And in the last one, f of negative x, means you're going to make the x values change their sign. So 2x becomes minus 2x. Okay, let's simplify that through a bit. And we can say that this equals 2x plus 2 over x plus 1 over 2x minus 2x. All right, so we need an LCD here to simplify. The LCD is 2x. All right, and you'll notice that 2x and that 2x cancels, so we don't have to worry about those anymore. This x, to get 2x, we multiply by 2, so you multiply the numerator by 2 to get 4. This 2x over here is the same as the denominator, so the numerator will remain the same. So your final answer then is 5 over 2x. Okay, so question B. Solve for x in terms of b by completing the square. What this means is, solve for x means that we have to finally have x equals something, and in terms of b means on the right-hand side of our equal sign, we're going to have our term with b in. All right, so starting, we know that we would need to have our expression x squared needs to have a coefficient of 1. So divide everything by 2. So we'll have x squared minus b over 2x, and I'm going to leave a space for my third term, and on the right-hand side, 8 divided by 2 is 4. Now for the middle term, remember that how we get that is we say a half times the coefficient of x, which is b over 2, and we square that. So in this case, that's going to be b over 4 squared, which is equal to b squared over 16. Right, so that's our middle term, or our term that we're adding. So we're going to add b squared over 16 here, and we must also add it on the right-hand side so that we keep the equation balanced. All right, now the left-hand side, this whole term here is a perfect square which we can factorize. So x minus b over 4 all squared is equal to, and on the right-hand side, let's get a common denominator there. So 16 is our common denominator. So the 4 becomes 16 plus b squared. Okay, sorry, apologies. Not 16, but in fact 64. Okay, because you're saying 4 times 16. Right, then at this point, we square root both sides. So we're going to say then the square root of x minus b over 4 all squared is x minus b over 4. Then on the right-hand side, we cannot square root the top, so we show it as 64 plus b squared, but the bottom, the square root is 4. All right, now we take over the minus b over 4 from the left-hand side, so we leave x on its own. So minus b over 4 becomes positive b over 4, plus minus the root of 64 plus b squared over 4. And to simplify, we can show that as one fraction on the right, so it's b plus or minus the square root of 64 plus b squared. All right, the word problem, question 7. A bricklayer and his apprentice build a wall in 24 days. When each person works separately, the apprentice takes 20 days longer than the bricklayer to complete the job. Remember, the apprentice is the helper or the person who's learning how to do the job, and he obviously is helped by the bricklayer. Set up and solve an equation to determine the number of days each person takes to complete the job on their own. Right, so what's useful here is to set up a little table. All right, so my table has the apprentice and the bricklayer and them working together, and in 1 day and on their own. All right, so they tell us that the apprentice takes 20 days longer than the bricklayer to do the job. So the question is, determine the number of days each person takes to complete the job on their own. So if we say that the bricklayer takes X days to complete the job on his own, then the apprentice takes X plus 20 to complete the job on his or her own. Right. So remember that means that that's an amount of days. So X plus 20 is amount of days in total that the apprentice will take, which means that in 1 day, he's completed 1 over X plus 20 of the total day's amount of work, which means that in 1 day, the bricklayer he's completed 1 over X. So for example, if X was 20 days, for example, then he would have completed 1/20th of the work in 1 day. And in 20 days, he would have completed all 20/20ths. So that means working on their own, they build the wall in 24 days. So that's the total of this column, okay, in working on their own. All right, and then the work done in 1 day means that in 1 day together, they would have completed 1/24th of the work. Now the key column we're using is this one, because we know that this value plus that value must equal this value. Okay, the total of them working in 1 day together will equal the 1/24th in total. So we can set up an equation then by saying that the 1 over X plus 20 plus the 1 over X is equal to the 1/24th. Right, so now we're going to multiply by the LCD. So the LCD in this case is X, well, let's say 24X into X plus 20. So we're going to multiply each fraction by that. So the X plus 20 in the denominator in the first one will cancel with the X plus 20 in the LCD to leave 24X. Then in the second fraction, this one, that X will cancel with that X to leave 24 into X plus 20. And in the last fraction, this 1 over 24, that 24 will cancel with that 24 to leave X into X plus 20. All right, now it's just a case of multiplying out. So we get 24X plus 24X, and then 24 times 20 is 480 equals X squared plus 20X. All right, so it's quadratic. So move everything over to the right-hand side, so we get 0 equals. X squared is our only squared term. Then on the left, we have 24X plus 24X, which is 48X. Take it over. 20X minus 48X equals minus 28X. And then lastly, the minus 480, which we've taken over. Right, so there's a quadratic which we can now factorize. You can use the formula if you need to. X minus 40 and X plus 12. So therefore, X equals 40 or X equals negative 12. Now remember, X is a measurement of time. Okay, it's an amount of hours. So that one is invalid because it's negative, which means that we can conclude and say that the bricklayer takes, now remember the bricklayer was X, so X equals 40, so the bricklayer takes 40 days to do the job, and the apprentice is X plus 20, so the apprentice therefore takes 60 days. Please remember to end off your answer with words. Right, question 8. Refer to the figure, the graphs of f of x equals ax squared plus bx plus c, and g of x equals p to the x plus q, are represented below. So the f graph is the parabola, given in red, and the g graph is the exponential curve, which is in blue. Then they tell us that y equals negative 1 is an asymptote to g. So they haven't indicated that on the diagram, so it's a good idea for you just to put that value in of y so that you can you can reference that from the diagram. Then the third bit of information is that F passes through the origin, and the turning point of F, 2, 3, is also the point of intersection of G and F. That means this coordinate is 2 and 3. All right, the turning point. Okay, question A. Determine the equation of F in the form f of x equals ax squared plus bx plus c. Right, we start with the turning point standard form, which is a into x minus p all squared plus q. Okay, and into that, we subs our turning point of 2 and 3. So 3 is our y value, and 2 is the x value of the turning point, so that becomes y is equal to a into x minus 2 all squared plus 3. Right, now secondly, we have to solve for a. So we can substitute another point on the diagram. You can't substitute the turning point in again, because then you're going to zero out your bracket x minus 2. It'll become 2 minus 2, which is 0 squared, and then you've lost the value of a. So we substitute the origin in. So the origin's y value is 0, and the x value of the origin is also 0. And so now we solve for a. So 0 equals a into 0 minus 2 is negative 2. Squared is positive 4. So it's a times 4 plus 3. So therefore, 4a equals negative 3. So a equals negative 3 over 4. Okay, then lastly, we substitute this a value of negative 3 over 4 back into this step of the equation. So y equals minus 3 over 4 into x minus 2 all squared plus 3. And then we must multiply it out because they asked it for in that standard form, not in the turning point general form. Okay, so we're going to FOIL out. So y equals minus 3 over 4 into x squared minus 4x plus 4 plus 3. Now distribute the 3 over 4, the negative 3 over 4, so negative 3 over 4x squared. Then minus 3 over 4 times negative 4 is positive 3x. Minus 3 over 4 times positive 4 is negative 3. Then plus the 3 that's on the outside, and now you can simplify the last two terms. Okay, so plus 3x minus 3 plus 3 cancels, so that is your final answer. Question B, determine the equation of G. So let's start off with the generic that they gave us. Y is equal to p to the x plus q. Now we already know that q is negative 1 because that's the horizontal asymptote. So we can straight away get rid of the q, replace that with a negative 1. Now we subs the point 2, 3. Okay, remember 2, 3 is that turning point of the parabola, but it's also a point of intersection with the exponential function. So the y value is 3, the x value is 2, and we know that that's minus 1. So bring the minus 1 over, we get 4 is equal to p squared, and therefore p is equal to 2. Not negative 2, positive 2, just 2, because it's a positive exponential curve above the x-axis, so the base, there can't be a negative on the outside of it. Besides, the base of an exponential function needs to be positive anyway. Right, so now we substitute that back. So y is equal to 2 to the x minus 1, so therefore g of x is equal to 2 to the x minus 1. C, write down the range of g. So the range of an exponential curve is from the asymptote to either positive or negative infinity, depending on which side of the asymptote the graph is drawn. So in this case, the range is greater than negative 1. Write down the coordinates of the turning point of f, remember, which was 2 and 3, if it undergoes a transformation of fx plus 4 plus 5. Okay, now this part here means it goes into the x value of your equation. All right, and x plus 4 implies a 4-unit translation to the left. So in our new coordinate, our x value of 2, we must subtract 4 to get negative 2. Then the positive 5, it's outside of the f, which means that's vertical. We're adding it to our y value. So 3 plus 5 gives us 8, which is the new turning point. Question 9. Consider the area A contained between the parabola and a horizontal line. So at the moment, the x and y axis is not important. We're only concerned about that area in between the two curves. So if B is the horizontal base and H the height as they've marked, in other words, they're implying that this is a right angle, which is important later. The area of A is given by the formula A equals 2/3 BH units squared, and the equation of the curve is y is equal to 6x minus x squared. If you want to work with that in standard form, it might be a bit easier for you as well, so I would just rewrite it as minus x squared plus 6x. Find the shaded area in both cases, showing all the working out. So we need to find the B and the H value. So now remember, this is the B value, and this here is the H value, which is in line with our turning point. All right. So in order to find the distance of B, we actually need to find the two intercepts. We already know that one's 0, but we need to look for that one. All right, so for the x-intercept of a function, you're going to let y equal 0. So for the x-intercept, if we let y equal 0, we have that equal to negative x squared plus 6x. So we can now factorize an x out. So we have x into negative x plus 6, and therefore our solutions are x equals 0 or x equals 6. Okay, that's what would give us the x-intercept. So that means that this value there on the x-axis is 6, which means our B is 6. For h, we need the y distance here, but we can work out the x value at the turning point, okay, by using x equals minus b over 2a. Now remember, don't get confused. This b does not refer to that b. It's from the standard form, ax squared plus bx plus c, that we're using that b. All right, so minus b over 2a will be minus 6 over 2 times the a value, which in this case is negative 1. And so that gives us negative 6 over negative 2, which is positive 3. And then for the y value, we substitute that 3 into the original equation. All right, so y is equal to minus 3 squared plus 6 times 3. Minus 3 squared is minus 9. And 6 times 3 is 18, which gives us a y value of 9. So that means h is equal to 9, because that's the distance from the x-axis to the turning point. So now we can go into our area. They told us that the area is equal to 2/3 BH. Right, so 2 over 3. Our B value we've worked out is 6, and our H value is 9. Right, so we can cancel. 3 into 6 goes twice. So 2 times 2 is 4, times 9 is 36 units squared. Okay, question B actually follows on. Remember, we already know that this whole area is 36 units squared from the previous question. So now what we need to do is to find out what that value is and what that value is, the x values. We know the y values are 5. So because we know the y value is 5, we can substitute 5 into our equation, which was negative x squared plus 6x, and now solve for x. So take the x squared over, take the 6x over, and the 5's already there, and so now we can factorize. Right, so x minus 5 into x minus 1 will give us 0. So therefore x equals 5 or x equals 1. They're both valid. X value there is 1 and the x value there is 5. So our new b value, this b value here, is 4. Okay, because what we're going to do is actually work out the area of the top part of the graph, because once we've got that area, we can subtract that from 36, which we worked out in A, to get the area of the shaded region. All right, you don't work out the area of the shaded region on its own in this question because it's an irregular shape. All right, so B, yes, is 4. And we know that the original H that we worked out previously was 9. So if this portion is 5, because we've got y equals 5 here, then it means the remaining portion must be 4. So in the small white part of the parabola, of which area we're working out now, b is 4 and h is also 4. So the area then, please don't squash your working out like I am here. Work underneath. There is enough space for you. I'm just doing it so that I can keep everything on the same screen. All right, so area of the big parabola is 36 minus 2/3 b value, which is 4, times the h value, which is 4. Put that straight onto your calculator to get 76 over 3 units squared. Question 10a. Determine the probability of throwing at least 1 6 in 12 rolls of a dice. Give your answer correct to 2 decimal digits. Right. So the probability of at least 1 6. So in 12 rolls of the dice, it's easier to work out the probability of at least 1 6 by saying 1 minus the probability of no 6s. It's easier to work out no 6s in 12 rolls than it is to work out 1. Okay, and because we know that these are the probability of throwing in 12 rolls is 100%, that you will throw 12 rolls, we can say that 1 minus the probability of, on the first roll, of not throwing a 6 is 5 over 6. The second roll is also 5 over 6. The third roll is also 5 over 6, etc. So that we can have 5 over 6 to the power of 12. And that gives us a 0.89 chance that we will throw at least 1 6 in 12 rolls of the dice. Question B. 40 men and 60 women participated in an election. 70 people voted for candidate A. Determine how many women voted for candidate A if the choice of candidate was independent of gender bias. Right, so independence rule will be that the probability that it was candidate A times the probability that they were women is equal to the probability of A and woman, the intersection. Right, so the probability that someone voted for candidate A, there are 100 people in total that participated, but 70 voted for candidate A, so that means 70 over 100 represents the probability of A. The probability that they were women is 60 out of 100, because 60 of them were women. Sorry, not women, but 100. And that equals, and we're looking for what the probability of A and woman is. So that will be our variable, and that's also over 100 because there are 100 people. All right, so that means that we can simplify the left-hand side to 0.42 equals x over 100, and then multiply by 100 so that x equals 42. So there were 42 people, 42 women who voted for candidate A. Question 11, the golden ratio is called phi, or the symbol in the Greek alphabet is as you see there, and phi is approximated to 1,618. Phi is an important number and has many special properties. So what I suggest you do, just to look up on this, it's quite an interesting number. If you go and Google the golden ratio and you see what its application is in nature, in design and those kinds of things. All right, so they have said to you, let phi equal 1,618,033,989. Question A, write down the value of 1 plus 1 over phi. So what they want you to do is, on your calculator, you're going to actually type 1 plus 1 over 1,618,033,989. And just as if by magic, you see that the value of this is 1,618,033,989. It's exactly the same. And if you've been concentrating, then in B, you will notice that it's exactly the same. How amazing is maths? So in math terms, we can therefore conclude that phi is equal to 1 plus 1 over phi. Question C, use the fact that phi equals 1 plus 1 over phi to solve for phi and show that phi is equal to 1 plus root 5 over 2. Okay, so this is the show that part. That's what we need to end up with over here without using that fact that I've squared there in pink. Right, so we're going to start with this portion here. Right, let's multiply through by phi so that we get rid of our denominator. So phi on the left times phi will become phi squared equals phi plus 1. All right, we can see that's now quadratic. So if we take over everything on the right-hand side, we end up with phi squared minus phi minus 1. Right. This is not possible to solve into two brackets because there are no factors of 1 that will add and subtract to give you negative 1. So we know we must use the quadratic formula because we can see that that is in third form. We're not going to be able to factorize it into two brackets. Right, so in the quadratic formula, phi is equal to minus b, so the b value is minus 1, so it'll become, let's do the substitution together, so it'll be minus into minus 1 plus minus b squared, which will be minus 1 squared, minus 4 times a, which is 1, times c, which is negative 1, and that's all over 2 times 1, which is 2. Okay, now all we need to do is simplify and hope that we end up with that expression. Okay, negative times negative 1 is positive 1, plus minus, in the third, negative 1 squared will be 1, then minus 4 times 1 times negative 1 is minus 4 times negative 1, which is plus 4, all over 2. And because we are looking for the plus or positive solution, we can then say that therefore phi is equal to 1 plus root 5 over 2. The negative solution, by the way, is invalid because phi can't be negative. Phi is actually a constant, as you saw at the beginning of the question. Which leads us swiftly to D. Explain why 1 minus root 5 over 2 is invalid. Because it cannot have a negative ratio. Okay, our ratio cannot be negative for phi. More on the golden ratio. Over the page, the golden rectangle is a rectangle in which the ratio of the sides is phi over 1, or approximately 1,618. Throughout the ages, this ratio has been recognized as aesthetically pleasing. Many buildings and works of art contain the golden rectangle. Two examples are the Parthenon in Greece and the United Nations building in New York City, where the ratio of the width of the building compared with the height of every 10 floors is the golden ratio. Right, so that's the pretty pictures. Let's look at the more mathematical rectangle. So rectangle 1 has sides x and y, with xy being the ratio of length to breadth. Okay, so we're looking at the length as a ratio to the breadth. Rectangle 2 is formed by creating a square of length y, so there's a square, and then obviously and y with the ratio of length to breadth being y to x minus y, because this value, if the original length was x and we make up a square of length y, then the new length that we've partitioned here will be x minus y. So the new ratio is y to x minus y. Right, so just to be clear, it's the ratio of this y to x minus y. The length to the breadth. Okay, over the page on page 19, the final page of the paper. If the two rectangles have the same ratio of length to breadth, then they are golden rectangles. Okay, in other words, the ratio of the big rectangle 1, x to y, will be equal to the ratio of the smaller rectangle y to x minus y, and that makes it a golden rectangle. So using the above equation, show that x over y equals phi, the golden ratio. All right, so we're going to start with the given equation. Right, so x over y equals y over x minus y. Now, you may be wondering how to even start that. Okay, so the idea now is we have to get the right-hand side of our equation to look like this. X over y equals 1 plus root 5 over 2. Okay, because we know that in a previous question, they told us that phi was equal to 1 plus root 5 over 2. That's what we worked out. So that's our aim. So at the moment, we don't have any 1 plus root 5. We don't have any values except for variables. So the best way is to solve for x. All right, and we do that first by eliminating the denominator. So we're going to multiply both sides by the LCD, which is y into x minus y. So we're going to end up with x into x minus y on the left-hand side and y squared on the right-hand side. Multiply out x squared minus xy. Now we can see it's quadratic, so bring over the y squared, which then equals 0. Right, to solve this, we're going to use the quadratic formula. So x equals minus b. So in this case, b is actually negative y, okay? Although the x and y are in that order, remember we're solving for x. So if we had to rewrite it, we would say minus yx, and then the coefficient would be negative y. All right, so negative times negative y for our b value, plus, because remember we've already decided the ratio can't be negative, the square root of negative y squared minus 4 times the a value, which is 1, times the c value, which is minus y squared. And that's all over 2 times 1. Okay, remember your substitution step's quite important. Now simplify what you can. So x equals y plus, and in the third, y squared, negative y times negative y, and then plus 4y squared. Okay, and that's all over 2. Right. Now, in the third, you can factorize out a y squared. So we'll have y plus third y squared into 1 plus 4. You might see where we're going with this. Over 2. Now, we know that the square root of y squared is y. And we'll be left with the 1 plus 4, which is 5. And that's all over 2. Okay, now we can factorize a y out. So x equals y into 1 plus root 5 over 2. Okay, and now I'm running out of space because I'm doing more steps than is actually necessary. I mean, in this step here, you can actually take out the y squared, factorize the y squared out, and take the square root of y straight out, so you can eliminate this step. And so, yeah. Okay, so lastly, we want to get rid of that y. So we can say divide both sides by y. So x over y equals 1 plus root 5 over 2. And the question is, show that x over y is equal to phi. But we know that 1 plus root 5 over 2 is equal to phi. So therefore, x over y is equal to phi.